So hello students, welcome to the next class. In today's class, we'll study what are the different materials which are used for seals. Then about filters, which are shown to you on the right hand side, different filters. Then we'll classify different types of filters. We'll study them. Next, we'll see what are strainers. We shall start with seal materials. So what are the materials which are used for seals? They are generally of two types. One is a natural rubber materials, other is elastomers, that is synthetic rubber. Natural rubbers are not used because they tend to swell and perish in the presence of hydraulic oil. Most commonly used materials for seals are elastomers, which are made up of synthetic rubber. These synthetic rubbers are usually made up of various compositions to meet the various operating conditions of hydraulic systems in order to make sure that your hydraulic systems are leak proof. So what are the different elastomers which are used? Some examples here: neoprene, nitrile, guanise, silicone, viton, and tetrafluoroethylene. So first one, neoprene. So neoprene is one of the earliest elastomer which is used as a sealing material. So this neoprene is a very tough material and it has a very limited temperature range, that is around below 65 degrees centigrade, or it is in the range of minus 65 degree Fahrenheit to 250 degree Fahrenheit. So these types of sealing materials are mainly used in systems using petroleum fluids. So next is nitrile, which is also called as guanise. So it is the widely used sealing material. It is very tough and inexpensive. It is cheaper compared to other sealing materials, and it has an operating range of minus 50 degree centigrade to 100 degree centigrade. So next one is silicone, which is also termed as Teflon. So this silicone has a very wide range of temperature compared to nitrile. So its temperature range is from minus 100 degree centigrade to 250 degree centigrade. So this silicone is mainly popular in rotating shaft seals. So this is types of material is used where the system run from very hot to very cold conditions. But this silicon has a very low tear resistance, so it is not used wherein the applications have reciprocating motion. The next one is Viton. So it contains 65% fluorine in it. So operating range for this Viton is from minus 20 degree Fahrenheit to 500 degree Fahrenheit. Last one is tetrafluoroethylene. Tetrafluoroethylene is the most widely used seal material in hydraulic system because it is very tough and chemically inert material. So this tetrafluoroethylene has a very low coefficient of friction, and it has a very higher operating range up to 700 degree Fahrenheit. So these are some of the materials which are used as sealing materials in fluid power systems. Now let's move on to what are filters. As you know, contamination of fluid is the most severe problem which has been faced in hydraulic systems. In order to make sure that fluid which enters the fluid power systems is free from contamination, filters are used. What does this filter do? These are the devices which are used in hydraulic system to arrest foreign particles or foreign materials from entering into the systems. You can see a small example. So before that, you should know what is the symbol which is used for filters when you are simulating in any of the softwares. So this is the symbol which is used for filters, showing inlet and outlet of the filter. And on the right hand side, you can see there in the center one, it is a filter, and when the fluid enters the filter, it arrests the foreign particles before these fluid enters into fluid power system. And a below figure shows you the image of a filter, showing different components of filter: bowl, filter element, and head assembly, along with the sealing. Now let's see what are the different types of filters which are used. So on the left hand side, you can see a image of different filters which are used in different systems. So type filters are mainly classified based on three types: based on the method of filtering, based on the size of the pores in the filter material, and based on the location of filter. And based on the location method of filtering, it is further classified as mechanical filters, absorption filters, and adsorption filters. And based on size of pores in the filter material, it is classified as surface filters and in-depth filters. And based on the location of filter, it is classified as intake filter, pressure line filter, and return line filter. This is the classification of filters. These are different types of filters. Now let's see one by one different types of filters. First one is a mechanical filter. So what is the mechanical filter? In case of mechanical filters, metal or cloth series is used for filtering or removing the dust particles from the hydraulic oil. So this method is capable of removing only coarse particles, that is size of the particles, if they are bigger, it removes only coarse particles from the fluid. So here the solid contaminations are contaminants are physically arrested, hence it is called as mechanical filters. You can see a small image of how exactly mechanical filters will be. A series of metal or cloth, you can see how they are, okay, how the dust particles get filtered when they pass through the filter, and these are the two images how exactly are mechanical filters. Now we'll move on to the next one. Next type of filter based on method of filtering is absorption filter. So absorption filters are porous and permeable materials made up of paper, cellulose, or asbestos as a filtering medium. Here the dirt particles are absorbed by the filtering medium and only the hydraulic fluid is allowed to pass through it. You can see an image on the right hand side. It will allow only hydraulic fluid to pass through it, not the dirt particles. So these types of filters are used for extremely small particle filtration. Next type of filter based on method of filter is adsorption filter. So adsorption is a surface phenomenon and it refers to the tendency of particles to cling to the surface of the filter. You can see an image how the particles which are present in the hydraulic fluid are clinging on the surface of a adsorption filter. If the surface area of the filter is more, then the adsorption of dirt particles will be more. If it is more, it will be having a greater filtering capacity. So filter medium which is used in case of adsorption filters include activated clay and chemically treated paper. This is about types of filters based on method of filtering: mechanical filter, absorption filter and adsorption filter. So next now we'll move on to types of filters based on size of pores in the filtering material. In that first one is surface filters. Surface filters are nothing but simple screens which are used to clean oil which is passing through the pores which are present in the filter. The thickness, screen thickness in case of surface filters is very thin. You can see an image also on the right hand side. Surface thickness, screen thickness is very thin in case of surface filters. Dirty and unwanted particles are collected at the top surface of the screen when the oil passes through it. You can see a small particles which are on the top surface of a thin film of surface filter. So these surface filters have a very low dirt holding capacity when compared to the other type of filter. The example is collector paper. Next one is depth filter. So these depth filters contain a thick walled filter medium through which the oil is made to flow. So here in case of depth filters, much finer particles are arrested and the capacity is more compared to the surface filters. You can see a image of how the thickness of wall is larger in case of depth filters when you compare it with the surface filter where the thickness is smaller, and more finer particles get arrested in case of depth filters. Now let's see a small graphical figure showing the dirt holding capacity of both surface filter and depth filter against pressure. You can see clearly from the graph surface filters have very less dirt holding capacity when you compare with the depth filter. Now let's move on to the last one, last type of filters based on location of filters. In that first one, intake filters. So intake filters are also called as inline filters. So in case of this, the filters are placed just before the pump to protect pump against any contamination due to oil. So these filters must be so designed to give a low pressure drop, or else what will happen is the pump will not be able to draw the fluid from the tank, because pump is present after the filter. So there should be a low pressure which must be created in the tank, so that the oil flows through filter, then passes through the tank pump, then to the fluid power system. In order to achieve this low pressure drop across the filters, a coarse mesh is used for filters. You can see a components of a fluid power system where exactly the filter is placed. It is just placed above the tank, just before the pump. So next type based on the location of filter is pressure line filters. Pressure line filters are placed immediately after the pump to protect the valves and actuators which are present in the fluid power systems. This type of filters are having very small and finer mesh, so that even the smaller particles which are present in the fluid get arrested. They should be able to withstand the full system pressure. So these types of filters which are present after the pressure relieving valve should be able to withstand the full pressure of a system. You can see a image where exactly the filters are present in case of pressure line filters. The last one based on the location of filter is return line filters. So as the name itself tells, return line filters, it means the filter is placed just before the tank, near the outlet of the fluid power system. So this is because the oil which is entering the tank from the fluid power system should not be contaminated. So these types of filters are used in order to protect the tank from contamination. So oils, when passes through the fluid power system such as actuators and valves, is not directly passed through the tank. It goes to the filter. After filtering, the oil is passed through the tank, so that the oil which is present in the tank is not contaminated. Now you can see where exactly the filters are located in case of fluid power system. So we are done with different types of filters. Now we will see which are the commonly used filters in fluid power systems. So there are two types. One is full flow filter. It means the fluid which is passing through the filter from a tank, it, it flows completely. Or the second one is bypass filter, wherein only a partial amount of fluid is passed through a filter which is coming from the tank. Let's see the first one, full flow filter. So in case of some of the hydraulic systems, there is a necessity that the complete oil must enter the filter element. You can see the flow of fluid as shown in the animation there. In such cases, full flow fluid filter is used. So these types of full flow filters are obviously very efficient in terms of filtering, but as the fluid flows continuously, there may be a chances that your filters may get clogged, which increases the pressure drop. It means there is pressure loss. So there is a back pressure which is created. In order to reduce this back pressure, these filters are generally provided with safety valve before it cracks when the filter is unacceptedly blocked and there is a back pressure created in the filter. You can see a small animation and there is a safety valve over here. So using this safety valve, the pressure is controlled in the filter which the next filter which is commonly used is a bypass filter. It is also called as partial flow of hydraulic fluid or it is also called as proportional flow filter. In some hydraulic systems, only a portion of hydraulic oil is passed through the filter instead of passing the entire volume of oil. You can see the animation how the fluid that is hydraulic oil is passing through the filter. So here the main flow is directed through the venturi, that is the restricted passage without filtration, and the remaining fluid will enter the filter. As the main flow passes through the venturi, there is decrease in pressure at the venturi. This pressure difference influences the filter to draw a portion of fluid through the filter, and hence they are called as proportional flow filters. Here the pressure drop of oil is very low when you compare it with full flow filters. So there the pressure drop is more in case of full flow filter because of clogging of filters. Because of clogging there is a back pressure created in case of full flow filters. So there the pressure drop is more, whereas in this case bypass filters the pressure drop of oil is low when you compare it with full flow filters. So this was about filters. So before we move on to the next one, that is the strainers, we should know how the particle sizes which are removed from the filter are measured. They are measured in terms of microns. The smallest size particle that can be removed by a filter is 1 micrometers. Now we'll study what are strainers. A strainer is a coarse filter. It is similar to the filter, but it is mainly used to remove larger particles. So what is a strainer? A strainer is a coarse filter whose function is to remove only large particles from a fluid using a wire screen. A strainer is usually constructed of a fine wire mesh screen or screening consisting of specially processed wire of varying thickness which are wrapped around metal frames. You can see the image, how the wire is wound over the metal frames. So it does not provide as fine screening when you compare it with filters, which provide fine screening of contaminated fluid. And this strainers provide less resistance to flow than filters. So strainers are usually submerged in the hydraulic tank itself and fixed in suction lines of the pump, as you can see in the figure there. The smallest size of particle that can be removed by strainer is around 150 micrometer, whereas in case of filters it is 1 micrometer. Thank you.